chimney, we interpolate it as being more of a solar chimney. Instead of articulated cornice at the top, we use the PV array. We use sunshades in the exact same way, except that we calculated the exact angle and depth that they needed to be. Instead of using brick, which has that fine texture, we used a rain screen panel system, which sort of has that same sort of fine grain texture. And then front porches and gardens are the same way, except the front garden is now a rain garden as opposed to just like grass. So when you look in plan, we had two types of units. The typical unit, it's a 3-bedroom unit, 2.5 baths, with the fourth sort of area as a flexible space that could be converted into a bedroom in the future. Part of the sort of parameters that Mikasa had given us was that we need to be able to accommodate a lot of different people, potentially intergenerational households. So we put in as many bedrooms as we could in as a condensed space as possible, while still being respectful of people's space, to be able to accommodate all those people. And then the live work unit, the ground floor is open, can be flexible, can be converted into a studio apartment, can be used for aging in place, or could be used for retail in the future. And then upstairs is the living space with 2 bedrooms above that. And of course, both units are capped with a PV array. And looking in section is where you can see how we started to implement those passive strategies that were on the psychrometric chart. So in terms of thermal mass, we had a concrete slab on grade, and we also used a thermal core phase change material as part of the gypboard on the interior of the exterior wall, if that makes sense. An effort to sort of keep some of that heat or block some of that heat. We used natural ventilation by careful placement of our windows where the operable parts were, as well as using a stack effect up the stairwell and out that solar chimney. And then we also looked at solar potential. When do we want to block the sunlight in the summer? When do we want to let the sunlight in the winter? And unfortunately, Sarah from WSP is not here to speak more in depth about our envelope design, but they looked very carefully at where the weather barrier was placed, where our variable vapor barrier was placed, and how tight we were making the envelope.
So after those, keeping the outside and using what outside does, there's still definitely a need for some active systems for providing thermal comfort as well as energy and water. And what we really tried to do here was, on the broadest scale, like as a strategic level, is really match the density and quality of the energy to the need. This was doubly difficult because, I forgot to mention earlier, but this had to be an all-electric building because there was no combustion allowed on the site. So we tried to use the natural heat that people generate, and rather than fight against that with air conditioning, we instituted a variable refrigerant flow system that would actually span 3 houses and have multiple zones, so you could simultaneously heat and cool, or actually transfer heating from cooling. So kind of taking heat gain from passive solar in the front and moving that to the back rather than having to actively insert additional sources of energy. The other thing we did was to recognize just how difficult the water component was to hit. We had to capture all the water. And in the process of storing and treating and reusing the water, we sought to exploit the excellent thermal buffering properties of water to act as both a source and a sink for both the space conditioning and domestic hot water purposes. Ultimately, those were all tied to an oversized geothermal field, which would significantly improve the coefficient of performance to help us hit our net zero energy goals. I won't even try to explain the spaghetti monster that's going on here, but if anyone wants to come talk to me afterwards, please do. I think that'll... and then we have to pay for it.
Okay, so most people want to know what's the bottom line. How much is it going to cost me? So you can see here we have a summary that we will present to the client. This is all broken down in CSI format. And what you have here is showing you the breakdown for the residential units, the site work, and then the total. How does that affect each and every division, and what does that cost per square foot? And of course, down in the kind of soft cost, which we would say, you would have any type of markups, your insurance, your bond, GCs, and fee. So once we evaluated everything, we came to a total number of, I'm not sure if you can see it, but it's about 9.3 million. The first pass we did at this, it was more like 10.3. So we did go through an exercise of value engineering, looking at material types, further tightening on the energy usage and what goes where and how much we need to utilize. So therefore, we were able to bring it down about $1 million. And just to kind of get further into the highlighted areas of what affects cost. So exterior envelope, as you know, that was very important, how tight we can make it to make the interior systems operate efficiently. So key things that were mentioned were the rain screen panels. That's where we looked at value engineering as well. We at first had the tactile panels and then ended up using the OCO panels. If you can see that section cut of the exterior wall, we have the rain screen at the far end on the outside. You have your wood furring, and then we have what's called a SIPS panel, structural insulated panel system. So you have a foam insulated sandwich between two structural end panels. And then on the interior, that's where we had that phased material gyp board, the thermocore, on the interior walls.